Hello everyone. Today I will present for you a presentation actually, really interesting about everything is going on with everything inside the world, from politics until the AI stuff. So for those that don't know me, I am a PhD student with Stefan. I'm working on the code completion engine. And as I'm from AI background, I am working also on the LLM stuff inside Pharo, mostly the code generation stuff. So as I'm from an AI background, I decided to create an organization called PharoLLM, related more to everything related to the LLM and the LLM more inside Pharo. You can access it and browse it and see what is the tools inside and the repository inside this organization. And also, well, if you are very interested in the LLM part, you can also download one of the image inside the PharoLLM launcher. You can, it's on the development version, but you can also use it, and it has already the tools. Actually, one single tool, but inside the future I will integrate more tools, and you can test and see and implement whatever you want. So to begin, I want to define what is PharoLLM, what's our vision, and a concrete example of the PharoLLM version. Let's say an example of the PharoLLM. Before we begin, as I said, I want to present to you what is PharoLLM. PharoLLM, it's a set of tools and libraries that it's integrated inside the Pharo image through the Pharo launcher. So you can actually discuss with an AI from Pharo. It's optimized to be integrated inside Pharo image. And of course, it's built to be extended by the Pharo community. The current tools that inside the PharoLLM organization now, it's for now it's Chat Pharo, but inside the future, once we have let's say a beta version, I will integrate more of the tools that you can see, like the Pharo Copilot, Pharo Infer, Pharo MCP, and the Pharo Hugging Face. A really interesting fact that I woke up today morning, Meta received a bill from Claude for $200 to $21 million because they burned 73 trillion token the last month. 1 month ago, also Microsoft received a bill for $500 million for using Claude. So the company actually what the company is saying now is actually, what if we can build our own models inside our company or our community, our team, etc. So that's why this is why PharoLLM is here. So to achieve this goal, first to be able to have an LLM ecosystem inside your community, inside your company or the team, you should actually have the tools that is capable of talking with these LLMs. Secondly, you must have the capability to train and fine-tune your own model. It depends on your task and what you want. And the last, what you want actually at the end, of course, to discuss with this LLM, to deploy this LLM inside the production environment. Luckily, I implement some of the tools, and we are implementing some of the tools, and we are continuing to implement some other tools. But this is actually the, let's say, I won't say that it's the hardest, but the more hard part is to able to train and fine-tune the model, because it takes a lot of resources, a lot of time to prepare the data, etc., etc. So what I want to present for you now is what if we can really train and fine-tune our own model and deploy it locally. For that, what I have a use case, it's Pharo Copilot. It's a completion engine based on LLM based on LLM, so it will fetch your context and it will complete at the cursor level. What does it mean? It means that now in Pharo, it completes one single token. If you type, let's say for example here ORD, it will complete one single token. But what if we can go beyond that? You don't see anything. But here, actually, what is going on, it's completing, you are inside a test, and you complete, you type self and A. It will complete actually the whole sentence for you. Self, assert, float, infinity, equals, etc. So it's not based on a heuristic, it's based on an LLM that it will understand what is your context, where in like the package, the class, the method, etc. And it will generate for you the suffix of your prefix. And as I want to deploy this really interesting use case, I am searching for testers. So if you want and you want to test this cool tool, you can just fill up the form, and I will discuss with you more details about how we can do that. So in order to achieve the things that what we did actually is to able to train and fine tune and to be able to have the multi-token code completion. What we did actually is we chose an open weights code LLM, the Chinese one. More specifically, it was a Qwen 2.5 coder and Melum model. Melum model is a model from JetBrains. It was pre-trained on I don't know how much trillion token, but a lot. And actually, what we're interested in, it was small models, like the 0.5 billion parameter and the 7 billion parameter, because we thought that this small model can run locally on the machine. And we had two approaches. First, we want the model to understand the Pharo syntax, because as it's a low resource language, it doesn't understand, or it might do some knowledge distillation to understand, but it doesn't understand itself the Pharo syntax. So what we did actually is known in the scientific world as continuous pre-training, that we pre-train and train the model to be able to understand the Pharo syntax, and then we fine-tune the model to be adapted to the code completion task. Now, it can be adapted to other tasks like code generation, for example, test generation, code documentation, etc., etc. It depends on what you want to do. Well, before training, this is where the phase of choosing. How did we collect the data? The data, it was collected from public repository GitHub. It was actually, this is from, I think, 8 months ago. It was 1,200 repository publicly available on GitHub. So it's actually most of the community. After some filters, because we don't want to be sued for malpractice, we choose the MIT license repository, because otherwise we might have some question about the code owner or who owns the code. Of course, the tonal format, because it's the most wide format used on GitHub repository. And we decided to choose that each repository that it's validated from Pharo 10 until Pharo 14, it's a good repository. Before Pharo 10, we think that it's an old code, so we didn't decide it, because the code completion task, it's accessible, let's say, task, and you don't want the LLM to complete some old method that doesn't exist yet. Once we prepare the data, we begin the phase of training and fine-tuning. As you see, the smallest model took 2 to 3 days, and it was actually on the GPUs, actually on 2 GPUs, H100. So it was running for 2 days and 3 days. And for the biggest model, the bigger model, 3 and 7B, it take almost 6 days to get the trained version. This is for understanding the Pharo syntax, and this is for the fine-tuning the syntax. Of course, the fine-tuning, it takes much less time because it's a fine-tuning. It's just an adaptation. It's not a rewriting of the whole weights of the model or some part of the model. Now, once we train the model and we adapt the model to the code completion task, we decided to do some benchmarks to be able to validate that our model, it really works on the, let's say, the offline benchmark. Now, this is why I'm doing the tester Pharo Copilot. So this is the offline benchmarking. But as you can see here, so the first, the Qwen 3B base, it's the model without pre-training. It's the base model. It's like from the China. It's like that. After fine-tuning, actually, we have 80% of precision. So it's better. And what we can see actually is Claude 4.5. It's an old now model. We have it as 95%. Now the interesting part that the 7B model, the fine-tune, is almost close to the Qwen 480B model and the Claude 4.5. So as you can see, as we can conclude from this small graph, that after we fine-tune a model and of course pre-train, train, and fine-tune, we can see that we can actually arrive to a certain level that we can have some cool results that almost close to Claude or Qwen, even though 7B model took like 5 gigabyte of RAM, and the 480B model, it took like 40 gigabyte of RAM, and Claude, well, you know. Anyways, now this was for the just understanding the Pharo syntax. What is happening when we asked him to be like in really real repositories? And this is what actually is most important, because understanding the syntax, we can like do it. But as you can see here, that the 7B model, the SFT model, the fine-tune model, it was 76, which is better than the Claude 480B model, and it's very close to Claude 4.5 model. So as you can see, we were able to fine-tune and train the model. Now, what is happening when we want to deploy the model and maintain the model? Because the model itself is just .safe tensor model, and it's sitting somewhere on some repositories inside somewhere. The thing that how can we deploy the model? Well, actually, to be able to deploy the model, we need to understand what is an inference engine. An inference engine is something that it sits between you as a user or a developer and the hardware itself, the CPU, the GPU, etc., etc. So without the inference engine, actually, you can't use the model itself. Now most of the people now is in Pharo and the Pharo community is doing the relation between the Pharo image and the cloud API, for example, ChatGPT, Claude, DeepSeek, etc., etc. And other people, of course, want to use local APIs like Ollama, LM Studio, VLM, etc. So the difference, actually, cloud APIs, you are paying for one single token per single token. The the local API, you are not paying, but you are actually running the model on your machine. So it means that if you don't have powerful machine, you can't run the LLM model. What actually I was working and I succeeded. Actually, it was I used an open source inference engine called Llama CPP. It is a community that defined and created the Llama CPP, and it was actually the same what we did Meta. Meta, when create the Ollama, it took Llama CPP and create the whole ecosystem, the whole website, and everything related to this, and now they are making money from that. What I did actually is I took Llama CPP and create what is called Pharo Infer, which is the inference engine, the next version of Pharo inference engine inside PharoLLM. To understand what is PharoLLM, Pharo Infer, mostly what is inference engine. The inference engine, as I said, without it you can't talk with the hardware, meaning that you can't talk with the model. So it's actually it loads the weights of the model inside the memory. It handles the memory context, the streaming, how to generate token, the users limit if you want to set users limit for the user, etc. So the inference engine actually it's the heart of the LLM ecosystem. Without it, you can't do anything. So you might ask yourself, okay, I don't want to use Llama CPP. What is the point of having our own model? First, of course, as I said in the beginning, the real cost of the AI, it's not mentioned now, but it will be mentioned in the next few years. So, meaning if we have the Pharo Infer and the inference engine, meaning that we can have privacy in your image. We can have reliability, so meaning that you can't. If something happens, you can you can debug the bug and understand what is going on if there is something happen. And the most important thing is that it's fully integrated inside Pharo. Now, of course, why we don't depend on OLAMA and LM Studio. OLAMA, when it was created, it was a community that it was their ideas were about creating an inference engine that it's capable of doing everything freely for everyone. But when they saw that the model is go even bigger, the last model of DeepSeek is 1.6 trillion parameter. So they decided to change their policies. So now, if you want let's say to use this bigger model, you should pay. It was free and now it's paid. Now I don't know for LM Studio, it might change their policies. So we don't know what is happening inside their infrastructure. Their infrastructure. Of course, when we have our own inference engine, meaning there is no cost, it runs on your local machine. It's optimized to be integratable inside the Pharo image. There is no limit, meaning that if you have 5 hours, you don't have 5-hour session. You can work as long as you want. Of course, you don't need the network. The privacy, it's yours, and actually, there is a problem. Here's big control, not the lack of control. And of course, here we have a small table that compare what's the difference between the pros and the cons of having our own inference engine. Of course, once we have an inference engine, it's not just we have it and stable and it's okay and we don't touch it. No, it's like you should maintain it, because if there is a changes inside the memory or the model itself, you should handle how the memory is loaded inside the model loaded inside the memory. If there is performance optimization, there are changing inside the models and the politics of the companies that generated the big models, etc. Now you might ask yourself about what is if I'm working inside a team. Okay, we have the model, we have the data, we have the model, we have everything, we have the Pharo inference engine. What I don't want to be able to run the model on my machine, because my machine it's not big enough, or I am working inside a big team, and I want my changes to be able to understand with this model. The thing that like there is multiple solutions. I'll present one single solution for now. That actually what you can do is to deploy the model on one single server and create the RAG, retrieval augmented generation. And actually what it can do is to read your reset changes if it is a GitHub repository. So it does mean that you don't have to fine tune the model. It's just a model optimized and trained. You just you have a RAG that it let the model knows of your recent changes. So to be able to understand what is a RAG, this is a small presentation to be able to understand. We have here, for example, the trained and fine-tuned model. You have the user, of course. You have your question. You have your database and the RAG model. And it will do a pipeline to pass inside your changes, and in the end, it will give you, let's say, not an old version of not an old answer of your question. It will give you answer based on the recent changes of your changes, if there is any change. Now, the most important thing inside this presentation, what I want to say is we can know what the future will come with you. You see that today is $200 million for a single company. Tomorrow you might have $200 billion. So PharoLLM is myself and the community is doing a lot of work about, let's say, to create a sovereign LLM ecosystem inside Pharo. It's not the best one, of course, but it has some potential. And of course, there is a limitation for this because it needs time to train and fine-tune, and the GPUs is not something publicly available. You should pay for that. The bigger model, if we want to go with bigger model, we need more resources and more data. And please, guys, so this is a very interesting thing. When I was fetching the whole GitHub to know what is the repositories that we have, we saw that there is a lot of publicly available, let's say, GitHub repository that it mentioned just the MIT, but it doesn't mention the license. So if I am training a model and I want to fine-tune my model on your data, so I need to know what is the license that you have. So if you don't have any license, so it's like it's a copyright. So it's you own the model, or you own the data. So I can't use your data to fine-tune my model or train the model. But if you decided to make it publicly available, please choose MIT license, so I can't be in jail in the next 10 years. So a small conclusion that we could have, that the local models is really interesting. It's really interesting because once it's fine-tuned, it's well fine-tuned and well trained, yes, on task, it can do good work, especially with competing with a bigger model. And of course, our vision is to create a sovereign local LLM model that runs on your machine, on your server, on your inside your team or inside your company. In that case, you don't be fired for I don't know, spending $300 million for something. At the end, I want just to present the papers that we did to fine-tune and train the model. The GitHub repository for the PharoLLM organization, the model itself. So if you want to see the model itself, it's on Hugging Face. It's something the same of GitHub, but for the models. And PharoLLM, I want to say that it's a strategic investment. It will take years to be able to have something stable and not in the development version. And contribution is very well done. I don't know the time. Yeah. Okay.
Thank you, Omar.